Hello people, welcome to Developer Notes. This is my first video and I am so thrilled. Let me tell you why I created this channel. My memory usually becomes a ghost town before a few days of the interview. So I will go over a set of questions before my interview. Now I would like to pass along what I have learned from my interviews. Does your memory become a ghost town before your interviews too? Then this channel is certainly for you. Developer Notes helps you to prepare all the interview questions in C, C++, especially on the Linux environment. And for this reason, operating system concepts will also be covered. I will also talk through algorithms and data structures, mainly lead code problems. I plan to recreate some of my interesting mini projects which may be crazy cool to work on and can be added in your CV. I will also be sharing the interview questions which I encounter at the end of this video. Stay with me till the end if this is your wheelhouse. Let's get into today's topic. Let's consider a group of source file and header files as an own private island. The first is Santorini and the next is Anafi and so on. So each of these islands can't see each other's symbols. These files are initially given to the preprocessor. Preprocessing is a text processing system which does textual substitutions. It is sort of an automated copy paste. It sounds like a nonsense but not. Anyhow, the result of preprocessing is a single file which is then passed to the actual compiler GCC. Each of these files is compiled independently. This single file is called translation unit or compilation unit. Translation unit is the basic unit of compilation in the compiled languages. It consists of the contents of a single source file plus the contents of any header files directly or indirectly included by it after being preprocessed. Or in other words, translation unit is what you get once the source and header files have processed through preprocessing. Multiple translation units are then linked to make one program. Here the GCC runs 4 times even if we write gcc space file1.cpp, file2.cpp, space file3.cpp and goes on. As the picture says, linker runs only once. Please note that incremental compilation is different from this. Let me show you guys an example. Here linkage ex3.cpp is a private island and so linkage ex4.cpp. Main sits in ex3.cpp from which function e is called. This function e is defined in ex4.cpp. Static variable counter is defined in this header file whose value is modified from both .cpp files. As we are concerned about the translation unit here, let me compile these files. Both of them compiled independently and produced .o files here. I'm gonna link these files together to produce an exe called ex34. Glad we got the output. Since we got the different address for the counter static variable, it meant that each of the translation unit got his own private copy of this variable. Because ex4.cpp has the counter value as 8, but ex3.cpp has 12. Now let me compile the files together by running a command g++ minus standard C++11 linkage ex3.cpp and the next file linkage ex4.cpp and the object file, let's name it as ex43. It's better to run the commands from the recent than typing your own. ex43. Anyway, this still resulted the same. So it proves that GCC has run 2 times for each of the source file and hence there are two translation units even if the files are compiled independently or together. Then here is a little tip that if you don't declare this function e in the header file and add the hash include linkage ex4.cpp in ex3.cpp file, you will be driven mad by duplicate symbols linker error. So have this forward declaration function e in h file instead of including the .cpp file in another .cpp file. Now that we have learned what is translation unit, let's grab a knife and fork, dig into linkage. Before jumping into linkage, we must know what is identifier. Identifiers are nothing but the name of variables, functions, and arrays. Compiled languages like C and C++ deal with linkage. Linkage refers to how these identifiers are linked by the linker. In C and C++, a program that consists of multiple source code files is compiled one at a time, like in the Santori island on the left. Until the compilation process, a variable can be described by its scope. For example, if I have a variable count in .cpp file, its scope ends at the end of the file. Scope is where we can access the variable R function. This explains that scope is handled by compiler. It is only when the linking process starts that linkage property comes into play. For example, the variable defined as global static is accessible only within its translation unit. Alternatively, if the variable is extern, it is accessible across translation units. This clarifies that linkage is handled by linker. There are actually two types of linkage, internal linkage and external linkage. Let's see what is an internal linkage. An identifier has the property internal linkage if it is not accessible outside the translation unit it is declared in. Static gives the variable internal linkage. Internal linkage refers to everything only in scope of translation unit and hiding it from other translation units. Let's see an example. I'm gonna pull up the same example I demonstrated for translation unit. In this case, static counter variable with internal linkage is defined in multiple translation units by including header exe3.h. Now I'm gonna compile them. We could see each source file has different address for identifier, in our case the counter variable. So this meant the modification on counter variable in the translation unit ex3.h, sorry ex3.cpp will not be reflected in ex4.cpp when we call this function e due to the storage class static. This program clarifies that we were not able to modify ex3.identifier's value from ex4.cpp. If we were able to, we should have got 13 instead of 8. And another cute little tip is internal linkage can only be implemented if the variable has global scope. Let's dig into external linkage. An identifier has the property external linkage if it is accessible or visible to every translation unit. Extern gives the variable external linkage. Externally linked identifiers are shared among translation units. Let's see an example for external linkage. I'm gonna change the static to extern here. Hope you might be aware that we should not initialize the extern here. So I'm going to take this into one of the .cpp files. So let me initialize it here. You can initialize it with any number. I'm going with the same number 7. Let me compile this. Let me save first. Okay, I save both the files and I'm compiling now, and it generated the exe file. We could see each translation unit has same address for the counter variable. So this meant that every translation unit shares this counter variable. So the value is reflected in ex4.cpp also. The same value is reflected in ex4.cpp also. We could see it here 1313. There you go. I pulled this off. If you find anything interesting and stupid, please leave a comment because I'm happy to hear from you guys. Make sure you hit the jumbo subscribe button and don't forget to click the bell icon so you don't miss a thing. Now we have come into the interesting part, the frequently asked questions which I had come across. So the first one is, what is translation unit or compilation unit? Come on, guys, I practically fed you the answers already, so sorry. I'm not gonna answer any of the questions here. I'm really sorry. And the next question is, if I want to access a variable outside its translation unit, what should be the identifier storage class? And the questions like difference between scope and linkage and examples for internal and external linkage. These are the questions I have come across. If you find this tutorial useful, please hit like and share it with your friends. To learn more interesting concepts, please subscribe the channel. I will meet you guys in another episode. Until that, a lot and lots of hugs and positivity.